This video shows the instructor solution to the ransomware victim assignment from the week of May 18th. First, we need to block all traffic coming from the ransomware victim into router R0. We'll create a standard access list. We'll use numbered access lists. Standard access list 10, deny 10.1.1.70, quad 0. Follow that with permit any to allow all other traffic. In the network here, the only host shown in this local area network is the ransomware attack victim. Then we'll apply this access list to interface G00, IP access group 10 in. Before we apply this access list, let's verify access to the ransomware server from the ransomware victim PC. Let's verify access from PC1 as well. Both of these PCs both have access to the ransomware command and control computer, which is out on the internet. Now we'll configure this access list and its application on the G00 interface, R0. So we can see we applied the access list to G00. Let's do a show running config now. Looking at G00, we have IP access group 10 in. And here's the access list. Now let's see what happens to traffic from the ransomware attack victim. Request timeout. Let's try ping. See if we can even ping the router. Destination host unreachable. However, this PC still has access to the ransomware server. Now let's block all traffic coming from the ransomware server into our network. Now it's important to note that our network has network address translation configured. Let's look at the running configuration on Edge. We use access list 12 to define the local area network address spaces. They're going to be translated using the address of gigabit 01, and that address is 209.165.0.2. Now on Edge, we want to configure an access list that's going to block traffic from this host machine. However, it's important to note that since there's network address translation configured on Edge, we have to look at the order of operations for processing traffic at the edge. First, inbound access lists are processed, followed by network address translation operations, followed by outbound access list operations. For a complete summary of order of NAT operations, you can go to this site, and this is an overview of the inside to outside order of operations and outside to inside order of operations for network address translation. Let's configure the edge router. We're going to apply this access list on the inbound of G01, which is the connection from edge to the ISP. Notice we cannot affect the ISP router. That's not our router to work with. We can only go as far as edge. Also here we have the named standard access list as opposed to a numbered standard access list, which we used up here. Again, the valid numbers for standard access lists are 1 to 99. Here we're using a named standard access list. And note the syntax, IP access list standard, and then the name that we choose. Okay. Copy. Go to Edge. And show IP access lists. So we now we have our deny malware server access list in place here. Now let's try to get there from this PC. Okay, request timeout. Now let's see what happened on this router. Notice we had 21 matches this time, and that's the HTTP access request coming from PC1. When we attempted to ping R0, let's clear this. We got 4 matches for the failed pings coming from this PC. So all traffic coming from the ransomware attack victim is blocked as well. Here we can look at our NAT translations that occurred. Okay, so we had 21 matches from PC1's attempt to access the malware server. And we saw that the traffic was blocked because of the timeout. Anytime you get a match count on a deny statement, that means the traffic was blocked. That concludes this instructor solution. Let's identify what we have here.